Hi everyone. As you know, I'm not there today. You can hear my voice is still sick, my son is still sick, so I'll be there tomorrow. So I'm going to change my extra help in the morning. I'll be here tomorrow morning, Wednesday morning, Thursday morning, and I'll be here after school on Thursday. What I would like you to do tonight for homework is make sure you complete yesterday's packet and today's packet. Today's is shorter. I'm going to walk you through today's notes. Okay, so you can use this video to help you with today's notes. Before we do that, I'd like to take a minute to recap where we've been. So can you please take out your colored packet, the learning goals packet? The front of it looks like this, and we began to fill it out already. We looked at the first page of learning goals about what a confidence interval is and why we make one. We talked about margin of error and how it changes with sample size and confidence level. So just take a moment to find that, and we're going to fill in the second page talking about the steps necessary to create a confidence interval. So take a moment, find that. So the steps necessary to create and interpret a confidence interval. I'm going to type these. This is where we make our four-step process. This is what we call the four-step process. Okay, and what I'd like you to do every time that you are asked to create and interpret a confidence interval, I'd like you to take the time to set your paper up into 4 quadrants. So you're going to set your paper up like this, and this is what I have been giving you. And again, it doesn't matter if you do it in 4 quadrants or 4 steps going down, but it's just a way to help you organize your work. And so let's write down what each of these are. So the first step is what we call state. And in that step, you state the parameter. And what the parameter means is something about the population that you want to try to estimate. So this is where we write the sentence, we wish to estimate the true whatever it is, and then we say with however much confidence. And that comes from the question, 90, 95, whatever it might be. Our second step is the plan step. So in the plan step here, this is where we check conditions, and then we name the inference method. So far the one that we've worked with is a 1 proportion z interval. Make sure that when you check your conditions, you're checking all 3. So you're checking random, independence, and for the 1 proportion z interval, you're checking your n times p hat being greater than 10, and your n times q hat being greater than 10. And you know, you can draw the hat. I just can't do it while typing right now. So we have the 4-step process is state, plan, do, conclude. So the do step is where we create the interval. And you can do this in your calculator by doing stat, test, and then find 1 prop z int. In the name here in your plan step, you cannot abbreviate. To show work, you're going to tell me what x is, you're going to tell me what n is, and you're going to tell me what z is. Remember, z comes from your formula book, and I'll show you that again in today's lesson. And the last step is the conclusion, or conclude. And so this is where we say we are, however confident, the interval from blank to blank captures the true proportion of whatever it is. Okay, so it's similar to the state step. So this is our 4-step process. Anytime you are asked to create and interpret an interval, you need all 4 steps. Another thing, the other goal that I want you to answer is how do we interpret the confidence level? And so the level I want you to remember is the 90% or the 95% or the 99%. That's what the confidence level is. And this is where we say if we were to take many, many samples and create a however percent, whatever percent interval for each sample, then about that percentage, whatever that is, of the intervals will capture the true, whatever it is we're talking about, mean, proportion, oops, sorry. So you examine this with the app. okay, that we played around on the computer. So if you took many, many samples and you create that type of interval for each, then about that many of the intervals, that percent of the intervals are going to capture the true value we're trying to find. Okay, it's not a probability. All right, so now that you have this written down, we're going to learn our next goal for today. So can you please go back to the notes? And our goal for today is, how do we calculate how large a sample is needed to stay within some given margin of error? So if you've ever noticed in all the questions we answer, a lot of them are like 1,002, a random sample of 1,002, or a random sample of 2,002 people was one that we looked at yesterday. Where do they get that sample size? Why not just ask 1,000? Why not just ask 2,000? And that's what we're going to look at today. So the first question, can you please add the 90% confidence? I forgot to add that to the question, so please just add that. And this is saying the General Social Survey found that 31% of adult Americans reported they were very happy. Suppose designers of this study now want to estimate the proportion of all Americans who are very happy with no more than 2% margin of error, or 0.02, and 90% confidence. So what I want you to realize here is that we are looking at proportions, okay, and we're looking at, we have the margin of error, and we have the 90% confidence. So what does all of this give us? Well, this tells us, off to the side, I can write, okay, I know that my margin of error is 0.02. I know my 90% confidence tells me that Z, and I can go to the table to get that Z, and it's 1.645. And I have a P that equals 0.31. But what I'm being asked to find here is what's N. I'm being asked to find what's the sample size. So what information we're given, we have a formula here. And the formula that we learned is the margin of error formula. Remember, your margin of error is your critical value times the standard deviation of the statistic. For proportions, the critical value is a Z, and the standard deviation is the square root of P hat times Q hat over N. So if we plug in these values and getting that Z from the chart from yesterday, so I have 90% confidence tells me, okay, I'm looking at 1.645, and that's what I'm going to plug in for my Z. I already know my P hat is the 0.31, so we're going to start plugging in some values. So if I plug in my margin of error, 0.02, my Z, 1.645, my P hat, my Q hat, I'm trying to solve for N here. So this is going to take us a little bit of algebra. So what I'm going to first do is divide both sides by the 1.645. When I divide by 1.645, I get this long decimal 0.01215 blah, 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 equals, and then I have the square root. So to get rid of that square root, I'm going to square both sides. So I square this side and I square this side, and that will cancel out the square roots. And so if I cancel out the square roots, then I get this scientific notation in my calculator. And now what I can do is I can cross multiply. Cross multiply, I divide both sides, and I get my N. But this needs to be a number of, sorry about that, this needs to be a number of people. So how many people is that? Well, I know if we were to do regular rounding, this would round down. But this means that if I'm going to stay within this margin of error, I need that fraction of a person. So to ask a fraction of a person means you are asking the whole person. So in this instance, we are always going to round up, no matter what this decimal is. That's different from what we did yesterday. So what you just did is figured out they need to sample 1,448 people if they want to run this survey with a margin of error of only 2% and 90% confidence. Okay, so in the real world, why do we need this? Well, we need this if you think about car companies and they're trying to do some safety measures on airbags and stuff. They don't want to crash more cars than they need to. They want to keep their margin of error really low and their confidence really high. So they'll use this formula to figure out, well, how many cars do I need to crash to keep my margin of error low and my confidence high? Because every extra car that they crash is thousands of dollars wasted. So we're going to do some practice now, and we're going to take some notes first. So in choosing your sample size, that was a lot of algebra that we just did. So what you can do is use the margin of error formula, like we just did, plug everything in and solve for N. If you don't like doing that algebra, then what you can do instead is I rearrange this formula. It's the same formula, just with the variables rearranged. If you want to use this formula, you must memorize it on your own. This is not one you're given. This you're given, this one you're not, so you'd have to memorize this. To be safe, remember, always round up because you need that fraction of a person. Okay? Now, what if this is the first study? So in that last example, we knew already that 31% of people felt very happy. This is the first study of its kind. What can we use for p hat? If we don't know the proportion of successes and failures, what would be fair to use? Can you think about that for a second? You should realize it'd be fair to use 1/2 or 0.5. Assume half are successes, half are failures. So we're going to do some practice together now. Okay, so the first one, suppose that you want to estimate the proportion of all students at your school who have a tattoo with 90% confidence and a margin of error of no more than 7%. So if I'm going to list out what I'm given here, I'm given my margin of error, the 90% confidence when I go to my table. The 90% I don't use, that's not a proportion, that just tells me Z. And since I don't know the percent of students who have a tattoo, I'm going to assume half do and half don't. Now, I know that's probably a very generous estimate, and it's probably less than that, but I don't have previous data to go off of. So if I plug everything into that N formula, Z squared times P hat times Q hat over E squared, I get this decimal, and to be safe, I always round up. So I would need 139 students. In this next one, again, you're being asked for N. A social scientist wishes to determine the difference between the percent of LA marriages and the percent of New York marriages that end in divorce. How large a sample? So when I see how large a sample, that's telling me, okay, I don't know what N is. No more than 7% margin of error, that's my margin of error. 95% confidence gives me this Z. Since I don't have a P, I'm going to use, okay, half the people are going to get divorced. So again, using the rearranged formula for N, I would get this, it's a decimal with 195 point something. I'm rounding up to 196. The last one, a politician wants to know the percentage of voters who support her position of pre-K being funded with taxpayers' money. What sample voter size? So again, that's asking me for N. I have my 90% tells me my Z. My margin of error 4%. So again, the way I'm getting Z is going from that table from yesterday. This one right here. Okay, plugging into the N formula that I gave you, the rearranged formula that if you were going to use, you need to memorize. I get 422 point something, so it means I need 423 people. I know this was a long video. What I would like you to do now is with a partner, with a calculator, practice the remaining questions. It's using this formula, and then there's also some review. So I'd like you to try that, okay? So go back, rewatch this video. Make sure you got all the notes down. I'll be here tomorrow morning and Thursday after school.